Hi everyone, welcome to my channel Edu-spectra. So now today in our class we will be discussing with the exercise number 2.4. So the first question is, determine which of the following polynomials has x plus 1 as a factor. Okay, so here they are asking you to determine which of the following has x plus 1 as the factor. So we know that if a particular polynomial is said to be a factor of another polynomial, then when we substitute the value of a in a polynomial, if we get a remainder equal to 0, so when we get a remainder equal to 0, it means that the two polynomials are completely divisible with each other. So if we get the remainder equal to 0, we can say that the given polynomial is the factor of the other one. Okay, so the first one is x cube plus x square plus 1. Okay, and we have to show that x plus 1 is the factor. Okay, so first of all, what should we do? We have to take this x plus 1, equate it to 0. So from here we will be getting what? X is equal to minus 1. Isn't it? Now what should we do? Substitute this minus 1 in the given polynomial. Okay, so we have to do p of minus 1 is equal to minus 1 the whole cube plus minus 1 the whole square plus minus 1 plus 1. Okay, so minus 1 the whole cube means minus 1 plus 1 plus minus 1 plus minus 1. Okay, so we know minus 1 plus 1 is 0. Okay, here also minus 1 plus 1 0. Okay, so after substitution we got the value of polynomial equal to 0, which means that our remainder is equal to 0. So if our remainder is equal to 0, we can say that x plus 1 is a factor of x cube plus x square plus x plus 1. Okay, so x plus 1 is a factor of the polynomial. Okay, so second one is x raised to 4 plus x cube plus x square plus x plus 1. Okay, so here also we have to show x plus 1 is a factor. So from here we can write x plus 1 is equal to 0. So from here you will be getting x is equal to minus 1. Substitute this minus 1 in the given polynomial. So we have to find p of minus 1 is equal to minus 1 the whole raised to 4 plus minus 1 the whole cube plus minus 1 the whole square plus minus 1 plus 1. Okay, we have to substitute minus 1 in the places where x is there. Okay, so minus 1 the whole raised to 4. Okay, so even power, so this will become plus minus 1 the whole cube minus 1 plus minus 1 the whole square is plus 1 plus minus 1 plus 1. Okay, so if you see over here, this becomes 0 plus this becomes 1 plus minus 1 plus 1 again 0. Okay, so here we will get the value of the polynomial equal to 1. Okay, that means that our remainder is not equal to 0. Okay, so if our remainder is not equal to 0, it means that x plus 1 is not the factor of the given polynomial. Okay, so you can conclude it like that. I hope it is clear. So similarly, third one also you can take it as a homework. There also we have to show x plus 1 is a factor. So move on to a fourth one. Okay, we have to determine x plus 1 is whether it is the factor of the given polynomial. So first of all, we know x plus 1. We can write x plus 1 is equal to 0. From here we will be getting x is equal to minus 1. Okay, so we have to find the value of p of minus 1. Okay, so substitute minus 1. Now before substituting, we can just open this bracket. So from here x cube minus x square minus minus 2. When you open this bracket, this becomes minus root 2 into x. Okay, here also when you open the bracket, x will become plus root 2. Okay, now we have to substitute this minus 1 in our equation. So minus 1 the whole cube minus 1 the whole square minus 2 into 1 minus root 2 into minus 1 plus root 2. Okay, so now we can simplify it. minus 1 the whole cube means minus 1, minus 1 the whole square means plus 1, minus into this will become plus 2, minus again this into this will become plus root 2 plus root 2. Okay, so from here we will be getting minus 1 plus minus 1 is what? It is minus 2 plus 2 plus. Okay, now root 2 plus root 2, they are similar terms. Okay, so that's 2 root 2. Okay, now minus 2 plus 2 is what? 0 plus 2 root 2. Okay, so we will be getting final value of the polynomial as 2 root 2. Okay, so what does this mean? This means that our remainder is equal to 2 root 2, but that means our remainder is not equal to 0. Okay, so if our remainder is not equal to 0, it means that x plus 1 is not the factor of this given polynomial. Okay, I hope it is clear. Okay, so our second question is, use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Okay, so here also it is just like a previous question. We have to see whether after substituting the value of x, whether we are getting remainder equal to 0. Okay, so the first one is 2x cube plus x square minus 2x minus 1. We have to check x plus 1 is the factor of this. So first of all, what should we do? Take this x plus 1, equate it to 0. So from here we will be getting x is equal to minus 1. Okay, now what should we do? We have to find the value of p of minus 1. Okay, p of minus 1 means substitute minus 1 in this equation. So 2 into minus 1 the whole cube plus minus 1 the whole square minus 2 into minus 1 minus 1. So from here you will be getting 2 into minus 1 plus 1 plus 2 minus 1. Okay, so minus 2 plus 1 plus 2 minus 1. Okay, so minus 2 plus 1 it is minus 1 plus 2 minus 1 it is plus 1. Okay, so minus 1 plus 1 is what? 0. Okay, so we got the value of p of minus 1 equal to 0. What does this mean? This means that our remainder is equal to 0. So according to factor theorem, we know if our remainder becomes equal to 0, we can say that it means that the two polynomials are completely divisible, and we can say that x plus 1 is the factor of the other polynomial. Okay, I hope it is clear. Now the second one also similarly, we are having x plus 2. You can write x plus 2 and equate it to 0. So you will be getting x is equal to minus 2. Okay, then substitute this minus 2 in your p of x equation. So when you will be doing, you will be getting the value of p of minus 2 as equal to minus 1, which means that our remainder is equal to minus 1. So since a remainder is not equal to 0, we cannot say that it is a factor. Okay, you can just substitute. So you can just substitute minus 2 in that equation and see. Okay, and move on to the third question. Okay, so our third one is p of x is equal to x cube minus 4x square plus 6 plus x plus 6, and we have to see whether x minus 3 is a factor of this polynomial. So first of all, we can take x minus 3 equated to 0. So we will be getting x is equal to plus 3. Okay, now what should we do? We have to find the value of p of 3. Okay, so p of 3 means substitute this 3 in place of this x. So you will be getting 3 cube minus 4 into 3 square plus 3 plus 6. So 3 cube means 27 minus 4 into 3 square means 9 plus 6 plus 3 it is 9. Okay, so from here we will be getting 27 minus 4 9s are 36 plus 9. Okay, now 27 minus 36 is what? Minus 9 plus 9. So here we will be getting the value of p of 3 is equal to 0. So what does this mean? It means that our remainder is equal to 0. So if our remainder is equal to 0, we can say that x minus 3 is a factor of this polynomial p of x according to factor theorem. Okay, so I hope it is clear. Okay, so now let's move on to the third one. The third question is, find the value of k if x minus 1 is a factor of p of x in each of the following. Okay, so here we have to find the value of this k. Now, if you see over here, in the question it is already given that x minus 1 is a factor of this given polynomial. What does that mean? It means that this x minus 1 and the given polynomial, they are completely divisible with each other, which means that the value of this polynomial's remaining term will be equal to 0. Okay, so from here, since it is already given it is a factor, we can write p of x is equal to 0. Okay, which means that we can write p of x is equal to x square plus x plus k. This equal to 0. Now we know x minus 1, since it is a factor, we can write x minus 1 is equal to 0. From here we will be getting x is equal to plus 1, isn't it? So from here we can find p of 1. P of 1 is equal to, just substitute this 1 over here and we can use the linear equations and just solve it. So p of 1 means substitute 1 in this place of x. So 1 square plus 1 plus k is equal to 0. So from here we will be getting 1 plus 1 2 plus k is equal to 0. So from here we will be getting k is equal to minus 2. Okay, I hope it is clear. So now let's do our second one. So our next one is p of x is equal to 2x square plus kx plus root 2. So here also, since it is given that x minus 1 is a factor of this, we can write the value of the polynomial equal to 0. So we know x minus 1 is equal to 0. From here we will be getting x is equal to plus 1. Okay, so from here we can write 2x square plus kx plus root 2 equal to 0. Now what should we do? Since x is equal to plus 1, substitute in this equation. Okay, this is your p of 1 we have to find. Okay, so p of 1 is equal to 2 into 1 square plus k into 1 plus root 2 equal to 0. Okay, now we can just solve it. So 2 plus k plus root 2 equal to 0. Now keep k in one side and bring the other terms to the other side. So we will be getting k is equal to, okay, this root 2 when it goes there, so we will be getting minus root 2. This 2 also when it goes to the other side, we will be getting minus 2. Okay, so the value of k is minus root 2 minus 2. Okay, I hope it is clear. Okay, so our next one is kx square minus root 2x plus 1. Okay, so here also it is given that x minus 1 is a factor of this term. So what should we do? Since it is the factor, we can say that p of x is equal to kx square minus root 2x plus 1 is equal to 0. Okay, the value of polynomial will be equal to 0. Now x minus 1 it is given, so we know x minus 1 equals 0 and we will be getting x is equal to plus 1. So we have to find the value of p of 1. This is equal to k into 1 square minus 2 into 1 plus 1 equals 0. So k into 1 square it is k minus root 2 into 1 it is root 2 plus 1 is equal to 0. Now what should we do? Keep k in one side and find the value. So we will be getting k is equal to, it goes to the other side, it will become plus, this goes to the other side, it will become minus. Okay, so from here we will be getting the value of k as k is equal to root 2 minus 1. Okay, I hope it is clear. Okay, so now the fourth one is p of x is equal to kx square minus 3x plus k. Okay, so now here also, since it is the factor of this, we can write p of x is equal to kx square minus 3x plus k equal to 0. Okay, now since x minus 1 is a factor, we can equate it to 0. So from here we will be getting x is equal to plus 1, which means we have to find the value of p of 1. Okay, so now substitute this 1 in place of x. So we will be getting k into 1 square minus 3 into 1 plus k is equal to 0. So from here we will be getting k minus 3 plus k is equal to 0. Now group the k's together. So k plus k minus 3 is equal to 0. K plus k is equal to what? Just 2k minus 3 is equal to 0. Now take this 3 to the other side. So you will be getting 2k is equal to 3. So from here we can write k. That's the same multiplication. When it goes to the other side, will come to division. So from here we will be getting k is equal to 3 by 2. Okay, k is equal to 3 by 2. Okay, so this is your final answer.